This video file is recorded in Sabancı University during the recitations for the CS201 Introduction to Computing course, as it was given in the fall 2016 semester.
Hello everyone, this is CS201 Introduction to Computing course, as it is given in Sabancı University. This is week 2 recitations, and as you can see, the new stuff is that probably until the end of the semester, although I'm not promising you, we're going to record our recitations, and you will have them. Maybe we're going to make them public as well, but we have not decided on that still, okay? Of course, as you know, as we already mentioned last week, 4 to 5% of your grade will be based on your attendance. That's why I'm going to collect it starting from this week. And the fact that you will have the videos probably does not mean that you should not attend. On the contrary, those videos should be something complementary, because I'm talking about myself as when I was your age, when I was an undergraduate student, I liked to study from after midnight till the morning, okay? This was my preferred time, and I was like, oh, why there are not videos or even recitations or lectures after midnight? Fortunately for you, we're going to record them, okay? You will have them, but of course I'm expecting from you to attend the recitations. It's not only about the attendance, but one of the reasons is that you can ask me questions, and if you watch my videos while we are not in the classroom, probably I'm not going to answer you. Don't expect a miracle to ask me through your laptop, and I'm going to respond to you. But here, you can raise your hands, and I'm going to respond to you. I reply to your questions and inquiries. What else? Probably you won't get an applause if you watch the videos. I won't be impressed, so please attend the lectures. This should help you in case of emergencies. Emergencies in terms of maybe you might be health issues, family issues, or whatever. So, as you know, I'm Artem Chamedi. This is my email, artemk@sabancıuniv.edu. My office hours are at Wednesdays from 4:40 to 6:30 p.m. Of course, you can email me at any time you want. If I'm in the campus, I also try to help you. In case of more emergencies, bigger emergencies, you can also call me, but I would prefer to first mail me, and then maybe you can get an appointment for extra office hours or whatever, okay? But you can better stick with this office hours, okay? Wednesday from 4:40 to 6:30 at FENS 2014. There's my office. Since we are not going to record the recitations again of the first week, I'm going to do a brief review of what we saw last week. So we are going to do some programming stuff. This is actually Introduction to Computing. We are going to program in C++. Remember C? As a tool, we are going to use Visual Studio 2012. Yeah, I know that there are later versions. 2015, I think, is the latest one. But since many of your friends have Mac machines, and the Mac version of Visual Studio that we distributed to you is kind of compatible to Visual Studio 2012. And also some of your homework assignment gradings will be automated. I encourage you to use Visual Studio 2012, at least when you are writing your assignments, when you are uploading your homeworks, okay? Your solutions, because some parts of your homeworks will be graded automatically, and we had some issues last year, 2 years ago, with Visual Studio 2015, okay? As I told you, 4 to 5% of the grade will be based on your attendance, and I'm going to start to collect it from today, and basically this is it. Now, you are a lucky generation, because since when you were born, probably you had a computer in your house. Sort of a computer, and you are used with them. But what do you think? The computers, what's the language of machines, of computers, of digital machines? Can they talk Turkish, English, Chinese? No. Actually, the language of computers, of machines, is the digital language. The only language they understand, whether it's your smartphones, your laptops, desktops, supercomputers, or whatever, is the binary language. They understand only ones and zeros. Even, I mean, I'm not going to go into details of what's CPU, what's input-output devices, what's memories, because probably you taught those kind of things at your high school, maybe even primary school. But let me remind you something. Let's say this is your screen. And as you already know, your screen, your monitor, has small dots. We call those pixels. Okay? So this is 1 pixel. They're very tiny. It's hard to see them. And what pixels, and the whole picture that you get on your screen is based on the arrangement of the colors of those pixels. Okay? Each of those pixels is a stream of bits. It's a string of bits. Okay? So let's say this pixel has this string, and don't take it literally. I'm just giving it as an example. Let's say 3 bits are for green. The other 3 bits are for blue. And the other one, I don't have a red marker, are for red. Okay? So the intensity of green, blue, and red is given with those 3 bits. And as you know, with combinations of those 3 bits, we can get any color we want. And we have the color of this pixel here. And it's not only for this pixel, it's for all pixels. This is how we get the picture. But what I want to emphasize here is that computers understand ones and zeros. This is the language of computers. It's not only with pictures the case, with monitors, it's with sounds also. Even when you do some arithmetic, if you say I want to add 2 and 5 and get 7, I want to get the result. What's 2 plus 5? The computers probably will do something like this. So this is machine language. If you want to add 2 numbers, it may be something like this, 0, 1, 0. This might mean to the computer add 1, 0, 1, and one number, 1, 1, 1, another number, and put the results here, and the result put it in another place, let's say 0, 1, 1. Let me write something else. If you want to, let's say, subtract 2 numbers, let's say 0, 1, 1 means subtraction for a certain machine, a certain computer. This is the first number. This is the second number. And the results I want to put it here. Okay? Are you comfortable with this? Yes or no? No, of course. I mean, no one that is sane would be comfortable with this kind of usage of machines, okay? That's why what programmers did came up with something better than this. It's called assembly language. Instead of adding numbers like this, they said, okay, let's write something like this. Add, for instance, some machines might use this syntax, this way of arrangement of things. A and B, and put the result to C. This means that C is equal to A plus B. Or if you want to subtract 2 numbers, you might do something like this. So x by z, meaning that z is equal to x minus y. Is this better? Definitely it is. But are you comfortable with this one also? You're comfortable? Maybe. Maybe. You think there's something better than this? Oh, well, instead of writing add a and b and put it to c, just say c is equal to a plus b. And z is equal to x minus y. Is this better? Definitely this is better. Okay. So this is where programming language is coming to play. Okay. Of course, the machine doesn't understand this. Neither does the machine understands this one. It understands this ones and zeros. That's why we have to compile it, basically translate it to assembly, and then from assembly to machine language, so the computer can work on that. Okay. Now, this is called programming language, and is the case with natural languages that we are speaking, English, Turkish, Chinese, Russian, whatever. It's also the case with programming languages that those languages have their types. Okay? What kind of types? I mean, this is going to be a brief review of what I'm going to repeat it again for the ones that just came here. This is a brief review for what we did last week. Since, as you can see, we are recording conversations. Okay, and we are not going to record the recitations on the first week. So, types. Very briefly. Probably you have seen those during the lectures. I'm just going to mention them briefly. So, data type. Let me write a table here. Let me draw a table here. Data type. And operations. There are many programming languages, by the way. I forgot to tell you about that. We're going to learn C++. Why? Because it's widely spread. It's very similar to other languages like C, Java, C#. And it's also a good way for you, the beginners, to study this language. Okay? So if you want to switch to another language, you might have it a bit more easier than that. Of course, there are many others, but I've just written those that are kind of compatible to C++. Python is also gaining ground last decade or so. Okay? Now, programming you might think is hard. You've heard maybe, I know, it's hard, I cannot do it, but believe me, it's not. And it will not be if you ask me questions. Please ask questions. It's not embarrassing to ask questions. It's embarrassing if you come here at 9:30 in the morning, 9:40 in the morning. You can be like 10 minutes late, but I'm not going to tell the others, don't worry. It's embarrassing if you come here and wake up and go without learning anything, because you're maybe embarrassed or maybe not interested to ask or so on. Okay? There are no stupid questions. So, even, not me, even the biggest hackers, the bigger programmers the world have seen, they have taken the first step in programming. They were on your desks, basically. Except for me. When I was born, I could program. So it's kind of weird. Okay, occasionally I'm going to do some jokes, so if you see me talking some weird stuff, you can assume that it's a joke, okay? So ask questions, please. Because if you don't understand the material of today, probably you will have problems 2 weeks from now. If you don't understand the material from 2 weeks from now, you will have problems 6 weeks from now, and so on. I call this the domino effect, okay? Ask questions. You can raise your hand, and I will reply to your questions. Okay, so in our everyday life, we have different types of data. One of them are integers. What's integer? You can have your seat. Integers are whole numbers. -3, -2, -1, 0, 1, 2, 28. What kind of operations we can make with integer numbers? Come on, you know maths. Primary school math, right? Can we add integers? Yes. Else? Subtract? Yes. Multiply? Yes. This is the multiplication sign, by the way. Divide? Yes. There's another interesting operator. For integer numbers, it's modulo operation. Do you have an idea what it's about? As far as I remember from last week, some of you had some prior experience. I think it was with Python during summer school for high school students for the crypto course, if I'm not mistaken. Was it? I think, yeah. Okay. So do you have a clue what modulo operator is? Modulo.
That percentage.
Exactly. Percentage. So what is this doing?
It takes the division and gives you the
Remainder.
remainder.
In Turkish you say kalan, I think. Very nice. So with this operator, you find the remainder. Okay? These are integer numbers. We have also other types, luckily for you, or maybe not luckily for you, unfortunately for you, depending on whether you like rational numbers, fractions, you have float and double data types. Basically, those are decimal numbers, floating point numbers, like, say, -3.2. What else? 105.3769, or 3.114159, or does this number ring you a bell? Have you seen this number? It's pi, yes. So it's a float number. I should have written it here. Okay, never mind. What kind of operations we can do with float numbers? Can we add float numbers? Yes. Subtract, multiply, divide. What about modular operation? Can we find the remainder of float number? Have you ever done it?
It's always zero.
It's always what?
Zero.
Zero. You think so? Actually, it makes no sense. The modular operator is not defined with float numbers. Let's see that. Here's a question.
Considering we don't have a memory problem, what's the point of using float when there's double?
Well, you don't want to waste your memory. Because
we don't have a memory problem, though, do we? Because we have to
as an engineer, it's expected from you that you're going to write your programs in as more optimized way as you can. Okay? Because when you write programs, you're not writing for your machine only. For an engineer, you're going to write programs that is going to be widely distributed. So how do you know that it's not going, he or she, the owner of the machine that is going to use your code, will not have memory problems? Maybe he's using a computer like 20 years old computer that has only 64 megabytes of RAM. You never know it, okay? So it's expected from you to pay attention to those things. But it's a kind of advanced topic from the perspective we're talking about, okay? Maybe we can talk this at the end of semester or maybe during the CS201 advanced programming course. Nice question. What kind of other data do we have? Chars. And chars are characters. Only one character. It can be a number, a letter, punctual sign, whatever, but only one. You write them in single quotation mark, like 1 is a character. What else? A is a character. Question mark is a character, and so on. We also have strings. There are operators defined on characters. We are going to talk a lot about those operators and operations that you can do with chars. You can define your own operators, by the way, but it's still too early for you. We have strings. Basically, strings are arrays, or how can I say it? Concatenated, merged characters. Okay, more characters form a string. It can be a word, even a sentence. So we write them in C++. So types in C++. We write them in double quotation marks. So R' is a string. Hello is a string, and so on. Okay. Well, this should be it. Yeah, of course.
What's the difference between float and double?
Float and double. Precision, because computers have not infinite memory. By the way, how many decimal points are after the point at the pi number? You know it? Infinite. But we don't have an infinite memory. You might have like 4 gigabytes of RAM. And eventually, if you use it for pi, it's going to overflow. You don't have more space. So it's double or more. The precision of double is more than a float. We are going to talk about this issue later on, maybe after 2 hours or so. Okay? This is called overflow, because you have a certain amount of memory assigned to each of those types. Number of bits, basically. And bit is 0 or 1 is called bit. We have here how many bits? 9 bits. Okay, now let's go and do some testing stuff that we did like for 5 minutes last week. And we are going to see today's code. By the way, you can download them from the professor's site. Okay, you know how to do it? If you don't know, let me show it to you. So you can look for prosecution. Okay. This is the second time I'm getting this message. By the way, before coming to the recitations, please download your codes. Okay? Again? What's the problem? Okay, finally. So this is the instructor side. You can go to current courses, CS, or better, go here, recitations. See? You click this. Lecture notes, maybe. Yes. So you can download your codes from here. Lecture notes, recitation 2. Okay? Do it right now. You can save it. You should save it. And after downloading, please do this stuff. Always. So your recitations probably will always be zipped file. They will be in a zip file. Please extract it first. Okay? We're going to extract it this way. Double click, extract here. And this is what we are going to get. Okay? And here are your codes for today. Before going with these codes, let's do some interesting stuff. Some testing, some review that we did last week. So start Visual Studio. Okay, did you download your file, the zip file? Extract it, please. Right click on that, extract it. Always do that stuff. Okay, so Visual C++, general, we'll start an empty project. Let's call it week 2. Tests.
I couldn't find the file. It wasn't in the station.
No, it's here. Lecture notes, and then recitation 2. Okay? Lecture note, recitations 2, and again, recitations 2. You can save it, you should save it, not worry. And then extract it. Okay. So, how do we add a new item? Right click. This part here. Add new item. Let's rename it. Like funny tests. Can be any name. It should be a C++ file. And C++ files have an extension of .cpp. Add it. And we are going to write this code that you should remember for the time being. So, char include iostream. If you have the suggestions, you can type first 2 letters, for instance. And you will have suggestions for that, for the type letter. Okay. Using namespace std integer main open the brackets, big ones, big parentheses. You should write return 0. Then C ignore. You remember those stuff, this stuff from last week, I suppose. By the way, there is a change in style, if I can say so. Instead of system pause that we have been using last week, you remember system pause, we are going to use those 2 lines, C in ignore and C in get. Okay? The reason is because of your homeworks, they don't work with system pause. That's why don't use it. Always my favorite way of doing things, and I'm going to show you what it's about. We already saw it last week. But cin, ignore, cin, get have the same, they are doing basically the very same thing. So use those two instead, because of the automatic grading for your homeworks, for your assignments. Okay. Now, why do we use this stuff? Firstly, let's run a piece of code. And do you remember what we're cin and cout doing? Cin was for? Come on. It was for input. Cout was for output, for reading, for printing data. All right, let's print something. So the syntax, you know what the syntax is. We went through that last week. You saw it during the lecture notes, so I'm not going to repeat it. Basically, it's the way the commands are structured in a certain language. Okay? Natural languages like English or Spanish or whatever have also their syntax. So cout, let's print the hello world stuff. That's if you're going to start to learn another programming language, this is the first thing that you're going to do. Hello world. We have end line. An end line is for taking the cursor to a new line. Again, cout. My name is Artrim. Now, you remember two kinds of errors that we can get while programming. They were which one? Which ones?
Syntax.
Yes, syntax and logical errors. There's an error here. What kind of an error is that? And how do you know that it's an error? Because we have this. Okay, let's not have an error first. Let's build the solution, basically compile the code. Okay. Let's enlarge the font. This should be okay, I suppose. So my name is Artem, it's working. You see the cursor is blinking here. But if I do the following change, if I add something more, end line, meaning after my name is Artem, there's another end line, the cursor is blinking here. Okay. Is this better? Oh, the previous one, the previous font was better. I think this is better. I hope you can see it. Okay. So far, so good. What if I do something like this? And I'm trying to compile my code, and I see that, well, there is an error. And you see this red dash. It can be red dashes. This is syntax error. Syntax error are very easy to detect. Basically, your tool, your IDE, Interface Development Environment, in our case, our tool that we're going to use for our programs at Visual Studio, points out those mistakes. So let's see where's the mistake. It's not compiling. You see those red dashes. An expression is expected. Can you tell me what is the mistake here? Why it's not working? Because I have those errors and I'm not printing anything. Okay, and you know, in the end of each comment, you have semicolon. If you have those errors, as you remember, you should print something. For instance, I'm printing this string here. This is string, by the way. Then I'm sending the cursor to a new line. And I'm trying to print something, but I don't print it. The compiler is expecting for me to print something, but abruptly I'm just putting semicolon. Okay, so this is a mistake. This is an error. And this is a syntax error. Okay? Because this is how the syntax of cout works. You have arrows, you print something, again arrows, print something. We can merge those two commands if you want. It's not a problem. Let's do it. We'll have the same result basically. So here we have two commands, and how do you distinguish between commands? If there's a semicolon, that is one command. So I'm going to erase this command. I shouldn't have cout because I already have it here. That's why I'm going to delete this cout. And this is it. It works. So I made out of two commands a single comment right there. You might do it this way, okay? Because I have here one semicolon. Questions? No. Let's go and do some arithmetic stuff. So let's define two variables, a and b. With this stuff here, a and b, what I'm saying basically is the following, that I'm saying to the compiler, okay, reserve a memory for two variables, which are of type integer, and their names are a and b. We have all names. Variables also have names. In those variables, I can put integer numbers as I want. So, you can imagine that those variables are basically places in random access memory. You can imagine them as kind of cute boxes like this. So I'm just saying that I'm declaring a and b. I've reserved the memory for a and b, but there's nothing in a and b. I want to read. I want to give some data to those. That's why we are going to use cin. The arrows are on the opposite direction. But before that, I should warn the user. I should tell to the user that something will give a and I'm reading a. Then I'm going to copy paste this code. I'm selecting copy paste. Give b. And I'm reading b. And now I might do something like this. Integer sum is equal to a plus b. What I'm doing with this command basically is something like this. I have another box which is called sum. And sum is equal to a plus b. But since a and b are not, basically, yeah, we should put values to a and b, and then we should find the sum. And I'm printing the sum. See out the sum is empty space, and I'm printing sum. This is it. Let's see how it's working. So I'm rebuilding it. Give a, let's say a is 5. And give 5 as input. Enter. Now give b, I'm giving 4. And the sum is 9. Let's go line by line. So with this command, hello world, end line, I'm going to a new line. My name is R3, it's printed. Then I've reserved a and b, they're in the memory. I'm saying give me a, and I gave 5 as an input. I pressed enter. I'm saying give b, I'm giving 4 as an input, and I'm saying calculating the sum as being a plus b. It's done here. The sum is 9. I'm printing the sum, and this is it. Okay. Questions? Actually, we saw this last week. Is this hard or easy? Okay. Come on, tell me. It's easy. Very easy. Instead of doing something like this, you can complicate your life. So you can declare sum here. With this comment, you're just saying, okay, reserve another cute box, which is called sum, and it's of integer type. And afterwards, I can say that this sum that you just reserved in the RAM memory, I can say to the compiler, well, this sum is equal to A plus B. Yeah, they're basically the same thing. Or I can merge them. I can say sum is equal to A plus B, semicolon, or do something like this. You might choose, maybe I think after a month or so, you will have your own style of programming. Just if you have written essays, I suppose, you have your own style of writing essays. This is the same. You will have your own style of programming. For me, the shorter, the better, but it's not always the case. Okay? Can we merge those comments also, those 4 comments, and do it in 2 lines? Yes. How can we do it? This is how we do it. We can write give A and B. So I'm going to erase this give B. And I'm going to read A. And I'm going to read B simultaneously, I mean at the same line. And I'm going to delete this C and D because I just read B. It's doing the same thing, but I should read them without any CL in between, without any text in between. So let's see how it's going to work. Hello world, give A and B, and I'm giving 5, and 9, 8, okay, enter. The sum is 13. So this is it. What if I say the product meaning the multiplication, A multiplied by B is, and I'm printing the sum. So there's no error, because if there's a syntax error, it's not going to be compiled. I want to find the product of A and B, so I'm writing the product of A and B, A multiplied by B, is what I'm printing the sum. This is what kind of an error? Logical error. So we have syntax, let's remember, logical errors. So I'm giving A and B. A is, let's say, 3. B is 5. And I'm saying the product A multiplied by B is 8, while it's 15. Yeah, this is the easiest logical error you can ever make in programming, probably. But your code is going to get long and complicated, and you're going to make mistakes that are really hard to find. Even the best programmers make mistakes, logical errors. That's why you have updates for your softwares, for your Windows, for your Office, for your whatever, okay? You can have your seat. There's ways you can find them. It's by testing, printing, breakpoints, but we will see them probably next week or so. So this was a kind of a brief review of what we did last week. Now let's go with the code which is similar to this one. Let's start with BMI. There are several ways. I mean, the code is already written. You should not write it. Sometimes we're going to write code from scratch, but not this time, because I want to show you some codes. You can do something like this. Select all of those codes, but you should first, I'm telling you, did you extract them? Otherwise, we have problems. If not, please raise your hand.
Extract
from the zip file that you downloaded from internet. Right-click on that zip file and select the Extract Here option. Okay? Okay, let me show it here. So, this is the zip file that you downloaded from internet. You just right-click on this one. Okay? Yeah, recitation 2.zip. You right-click on that and press Extract Here. Okay, nothing else. and you will get this folder. Now, you can select all of the files, CPP files here, copy them. Okay, are you following me? Copy all of them. Okay. Then go here. See where it is the project. Right-click on it and select Open File in Explorer. You will follow the solution where the project is. You see the funny test that we already write that code. It's here. You just paste it here. Nothing else. Did you do this stuff?
Paste where?
Again.
You don't have that.
You should have, if you install it, you should all of that, all if you have that, even in Mac machines. So, right-click here. Okay. Then you have Open File in File Explorer. You don't have it? Who wants to accept it?
Course application tree.
No. Okay, we'll check it. We'll check it afterwards.
I just right-click source files and paste it there. Does that work?
It's working like that also. So open folder in File Explorer and paste it here. Okay. Now, we are finished with the funny test. Let's remove it, not delete it. Remove meaning we don't take it into consideration. If we delete it, we will not have it in our folder. Now right-click it again, add new item. Now add existing item. And you should select BMI. Okay? And you can press F. This is it. If you, I copy pasted all of them. You can copy paste only one, so copy. Go here, open file, you can paste it. Okay. Or you can do something like this if you are more, if you feel better like that. You can open this file, let's say, go to bmi.cpp. Are you following me? So you can open the file, open with, let's say, WordPad. This is better maybe for you. And this is the code here. You can press Ctrl A, or you can do something like this. Select all. You can select all of them. This is WordPad. Okay. Select all of the code. Right-click on the code somewhere. Press copy. We have copied the text. Now you can go to source file. Okay. If I'm going too fast, just stop me. You can go to source file, add new item, CPP file. We can rename it, let's say bmi2. bmi2 is empty, but we can paste our code here. Right-click somewhere, and this is our code. Okay. So either you can copy-paste it or open with and write the code. And you remember this stuff of add new item from last week. Now, I'll take like 5 more minutes before the break, because this code is easy. What is this code about? Have you heard about body mass index? Yes, and what is it? You haven't heard about it? Okay. Allegedly, body mass index is metrics to measure your health. It's the ratio between your weight and the square of your height. So there are some limits. If you are below that limit, that means that you are thin. Otherwise, you're overweight. Okay? Underweight, overweight. Something like that. And we should write a program that we should give as an input to that program our weight, our height, and it's going to find our BMI, body mass index. So the abbreviation is BMI. Let's see how it's working. First, let me run the code. Don't forget, always put C in ignore, C in get. Otherwise, you won't see the output. It's going to exit immediately. So, but pay attention. For the time being, the Visual Studio works like this. You should have only one main function. Okay? For the time being, you should have only one CPP file here. If there are multiple files, don't delete them. You should just remove them. So let's say I want to remove BMI. I just right-click on BMI CPP and remove it. Okay? The code is the same. So you should have only one CPP file for the time being. Okay? Now, did you put C in ignore, C in get here? Hope yes. This is the code. I hope you can see it. Okay, let's run the code. Let's compile it. They're asking for me to enter my name. Okay, my name is Martin. Your height. I don't know it. Can you help me? I don't know my height. How tall am I?
180.
180? Okay, it makes sense. Let's have 180. By the way, it might be a question in your midterm. What's the height of your TA? Joking. Okay, so what's my weight? What do you think?
75.
75? Let's make it 75. So my R train, your height is 180 meters, not meters. In meters. Oh, my mistake. I should give it in meters.
1 point.
Let's run it again from scratch. So, okay. My name is Martin. Your height in meters. I thought it was in centimeters, so it's 1.80. Your weight in kilos is 75, and my body mass index is 23.40. I think it's okay. So I'm not overweighted or underweighted. This is how it works. Now let's go through the code. Or you want to get a break before going to the code? What do you think? Want to have
Yes.
a break? Okay. We'll be back after 10 minutes.